Welcome. I'm Mark Higgins, the Chief Operating Officer of Strategen, and I am delighted to be emceeing this morning's webinar on energy storage as a wholesale market participant. So this is part 3 in a webinar series on energy storage produced in partnership with Sandia National Laboratories and with funding from the U.S. Department of Energy's Office of Electricity Delivery and Energy Reliability. So I want to thank our partners for their support in this. Before we get started with the content, though, I want to go through some logistics for everybody. So how we use GoToWebinar. Basically, there's going to be this little panel that you see here. Everybody who's an attendee is muted. That will be always the way it goes unless we actually unmute we're basically going to be unmuting our panelists when they are giving their content, but everybody else stays on mute. We will be taking questions, but the way you type a question for us is you enter it into the little question box in your GoToWebinar pop-up menu. So we're not going to be using raise hand, and we recommend that everybody make sure that they're using a combination of the web-based screen so you can follow the slides, as well as dialing in either via your computer audio or a phone call. So the slides will be posted after the webinar is complete, and the webinar recording will also be posted. The webinar itself will run approximately an hour, allow a little bit of extra time at the end. Sometimes they run a little bit long. Ideally, we'll have about 45 minutes of presentations and about 15 minutes of Q&A. Okay, so as I mentioned, this is the third in our series. The next webinar that's coming up will be on July 12th. That's a Thursday, and that will be on rate design trends for behind-the-meter storage. So we'd welcome for you to sign up. If you're interested in signing up, you can sign up at the link down at the bottom. Okay, just a little bit on Strategen. We work on all sorts of grid modernization issues. So here's some information about us, but this isn't about us. This is about the content that we're working on with Sandia here. I do want to invite everybody to attend Energy Storage in North America. It's coming up in November in Pasadena. If you find this content interesting, there's going to be a lot of really great content there. We're actually doing a lot on the future of power system and transportation this year, and then we're bringing together policymakers from all around the world to talk about regulatory reform and market design for energy storage. So information there. Also wanted to highlight the fact that this webinar series is actually part of a broader energy storage knowledge hub that we run in partnership with Sandia National Labs and with funding from the U.S. Department of Energy's Office of Electricity Delivery and Energy Reliability. Another part of that knowledge hub is the Global Energy Storage Database. This is the go-to resource internationally for information on what's happening with energy storage deployments. Got a link down there to the website, and if you have a project, welcome you to submit it. That's how we have a vibrant and robust database of what's happening in the industry, is through third-party project submissions. All right, now I would like to turn it over to Jackie Hernandez from Sandia National Laboratories for a moment to give an overview of some of the work that Sandia is doing in the energy storage and grid modernization space. Jackie, you are live.
Hello all, my name is Jacqueline Hernandez, Senior Member of Technical Staff in the Energy Storage Technologies and Systems Group at Sandia National Laboratories. We are managed by INTEST, a subsidiary of Honeywell International. The slide you see is from my Senior Manager, Charlie Hanley. It provides a snapshot of the work we do in the national interest. This webinar series is consistent with our work in grid modernization and resilient infrastructure, with today's session covering our thrust area of an equitable regulatory environment for energy storage. So on behalf of our sponsor DOE and Dr. Emery Zook, who manages the OE Energy Storage Program, as well as my manager, Dr. Babu Shalamala at Sandia, I welcome you and thank you for participating in today's webinar about wholesale markets and energy storage.
Great, thanks so much, Jackie. Appreciate it. Okay, now I'd like to introduce you to today's moderator. Mahir Dasu is a manager on Strategen's consulting team, and Mihir has a great deal of expertise in wholesale market design and best practices in terms of what's happening nationally. So he's going to provide a bit of an overview of, setting the scene, what's happening nationally, and then we're going to go into the individual panels. And maybe, Mihir, you can give a quick outline of who we have on the webinar today and when they'll be speaking, just for the audience.
Great, yeah. So today we have a fantastic panel. We've got leaders from each of the 4 ISOs here to talk about what is going on with respect to energy storage developments and participation models within respective ISOs. So today's panel includes Michael DeSocio, who's a senior manager of market design at NISO, and he is the lead in energy storage market design and Order 841 compliance. Then we'll go to Laura Walter, who is the senior lead economist of the Advanced Analytics Department at PJM, and she's leading the efforts for 841 compliance at PJM. And next we'll have Kevin Van Noy, who is a director of market design at the Mid-Continent ISO, and he is leading up the efforts there. And our final panelist who will be speaking today is Christopher Parent, who is the director of market development at ISO New England. And then we'll just kind of round it out and open it up for Q&A after our panelists. So let me just take you to the agenda one more time, just to take a quick look, and I'll dive right into the background of FERC Order 841. So 841 applies to all the ISO regions except for ERCOT. So you can kind of see the map of these here. And so it started out in 2016 when FERC opened up a docket requesting info about DER aggregation and storage participation in the RTOs and ISOs. They issued a notice of proposed rulemaking to kind of gather information about what is the current state of energy storage participation, and how can these participation models be opened up further for energy storage. I'm sure many of you have heard of the value stacking of energy storage. Well, part of the impetus around this order was to enable energy storage to participate in multiple market products and leverage value streams from each of those. So FERC released the order in February of this year, and actually held another technical conference in April related to DER aggregation, and is currently taking some motions for rehearing, and the order compliance will begin in December of 2018. So between April, and we're currently in the period, and December, each of the ISOs and RTOs will develop their proposals for stakeholder and include stakeholder engagement at the same time. Implementation, the deadline for that is in December 2019. So we're looking at a couple of years of some interesting processes related to that, and audience members, this is a great time to get involved. So what does Order 841 do? So basically, it calls for all the ISOs to establish a participation model for energy storage. And there's 5 sections of the order, and part of it is to open up the markets for all market products, so capacity, ancillary services, and energy. Currently, a lot of the ISOs have separate market products. Energy storage can participate as a demand resource or a generator resource, and in each of those, some ISOs allow for market participation in the capacity market or the ancillary service market, but a lot of these market participation models don't allow energy storage to participate in everything at once. And so there's some work to be done there. The order also asks the RTOs and ISOs to account for the physical and operational characteristics of energy storage. So this gets into who manages the state of charge, who sends the dispatch signals. The order actually asks that the ISOs put together a model where the owners of the storage systems can actually manage their state of charge. But it doesn't necessarily have to be mandatory, but just an option. Another part of the order is that the participation models should have a minimum size requirement of 100 kW. And this could apply to aggregations or just the minimum resource size if you're participating in front of the meter. And also, energy storage should be able to set wholesale market clearing prices as both a buyer and a seller. And finally, that energy storage should receive wholesale LMP prices, locational marginal prices, for charging energy. So here's kind of a map or heat map of current compliance status at each of the ISOs. This is a little simplified, but some of the detail involved in this is where the rubber hits the road here. So I think I mentioned this a little earlier, but some parts of this order get into how energy storage within a single participation model. So if it's a demand resource or a generator resource, how does it participate in each of these provisions? So capacity, energy, and ancillary services. And I think that's where a lot of the detail is going to be discussed and developed within the separate ISO stakeholder processes. In addition, there's going to be some more work to be done on DER aggregations, distributed energy resource aggregations. FERC, in their original NOPR, included this notice of proposed rulemaking included both energy storage and DER aggregations, but they bifurcated the process and decided to implement an order for energy storage, but wanted to get more information on the docket and in the process to rule on how ISOs should implement DER aggregated resources. And here's just a bit about what the NOPR says and what FERC is going to do in terms of creating an order for that. So each of the ISOs have unique stakeholder processes, and this is just a little bit of information about how you as audience members can get involved. So in a few of the ISOs, the stakeholders are kind of serve in an advisory role. In NISO and PJM, stakeholders actually are within a shared governance process. And in CAISO, we have a governor-appointed board that actually determines the final rulemakings there. So, unique flavors for each of the regions here. So that's just a little bit of background, and now I am opening it up to the panel to dive into the specific details of each of the ISOs, and we're going to start with New York ISO. Mike, we're going to have you on the line. So Mike DeSocio is a senior manager market design at NISO, and he's been involved in the evaluation, design, and implementation of wholesale electric markets at NISO for over 20 years. And he has been overseeing this process with respect to energy storage participation models for a while. So Mike, I am going to open the line to you, so you should be able to speak now.
Thanks, Mihir. Thanks for having me, and I look forward to presenting what's going on in New York here. I wanted to start with just a little bit of background on the New York ISO, so if we go to the next slide. New York is roughly a 30,000 megawatt peaking region, and we actually carry roughly 42 to 43,000 megawatts of installed capacity to meet that peak. And in 2017, from an energy perspective, New York consumed roughly 160,000 gigawatt hours. So I thought that would provide some perspective on the size of New York's market, and kind of set the stage for what we're doing here in New York. If you go to the next slide, the governor and the state has been very active, as probably many of you know, with regard to energy policy. And in specifically, the governor has been very focused on clean energy direction, as well as supporting the maintenance of nuclear facilities, and more recently, earlier this year, laid out a plan to build 1,500 megawatts of storage by 2025. So New York State has been very active in its energy policy, and in particular how we can improve the penetration of clean resources while making sure the grid remains resilient. So if we go to the next slide, the NYSO has been really focused on supporting the state and thinking about how the energy future is unfolding. And as we think about it, we see the grid of the future really changing from a unidirectional grid where supply is generated from central station power plants and delivered to load, to now a multi-directional grid where we have active resources both on the supply side and the demand side. As we think about how we would manage the grid in that state, the ISO really believes that the need for resource flexibility will be key, and ultimately that will help maintain grid resilience. So as we think about our markets and how we're going to transition to support that future grid, energy storage plays a really key role in that. So if we go to the next slide, the NYSO has been thinking about integrating of storage and DERs for some time now, and on this page, the three document pictures that you see there are actually active links. So later, after the webinar, if you wanted to actually download those papers, you can just click on those icons, and they'll bring you to the documents. But we've been working with our stakeholders and market participants on developing energy storage rules now since late 2016. And we're thinking about storage both from a in front of the meter perspective as well as a behind the meter perspective, where storage may participate more in a DER participation model versus storage participating as the FERC Order envisions as an ESR participation model, or energy storage resource participation model. So if we go to the next slide, I think we can probably skip the next two slides since you provided a really nice overview of that. But in New York, we do have a lot of storage already in the queue. There's almost 800 megawatts of storage already in the queue, and the queue is actually changing pretty rapidly with more projects coming almost every day. So I thought that was helpful just to give a perspective on what we're seeing from an interest perspective in New York. And if we go to the next slide, I'll jump into a little bit of our design overview. So as we think about our participation model, we're really thinking about a model that's technology neutral, and really that means that it should be workable for pumped hydro, it should be workable for lithium-ion battery technologies, as well as flywheels or any other thermal technology that might be out there. And we've been really thinking about how to push the efficiency to the maximum extent possible. So how can we get the interaction of the storage into the market in a way that maximizes the use of the storage and improve the market efficiency? So we've been thinking about how how we would actually incorporate storage in both a dispatch but also a unit commitment perspective. And what I mean by unit commitment is some storage actually has transition states where they can't fully move from a discharge to a charge instantaneously. They actually need to transition through zero and then maybe mechanically or through some other switching, then actually transition the asset to a discharge or charge state. And so the model we're thinking about will allow for that. We are looking to modify the model to allow offers to be as small as 100 kW. FERC was very clear on that rule, and today that's different than today, where New York has offers. The minimum offer size is 1 megawatt. So this is a little bit of a change for us, but we're very prepared to make that change, and we're looking forward to relaxing that constraint. Storage will not only be able to provide energy and capacity, but also be eligible to provide reserves and regulation. And when storage is withdrawing from the grid, it would be treated as a negative generation rather than negative load. And the reason I bring that up is today in New York, a load is charged a load-weighted zonal rate. For storage, storage would be charged the nodal rate, which is important for those of you that are looking to develop in New York. If we go to the next slide, this gets into some more details about what kind of constraints and what kind of different parameters we're looking to offer for the bids that asset owners would submit. So in this slide, really we're talking about offers that accommodate a range from full injection to full withdrawal. So in the market in New York today, we do limit the offer to be between 0 and the maximum injection for an hour, or 0 and the maximum withdrawal for an hour, which has worked fairly well for pumped hydro over the last 20 years. But going forward, as we see new technology emerging, we recognize the need to relax some of that and enhance the model so that it can accommodate new technologies that are much quicker responding, like lithium-ion batteries. So the next slide really gets into the management of state of charge. And New York ISO has been working with its participants on 2 different options. Both options will be available and could be selected by the market participant. We're thinking on a daily basis, but we're still working with our market participants to nail that down, where they can opt to have the ISO manage the state of charge, where we would respect the parameters of upper and lower storage limits, as well as monitoring the state of charge telemetry signal to make sure any schedule we give the storage asset is feasible and stays within the physical constraints of the asset. The other option is to allow the market participant to manage that state of charge themselves. And so those will be optional, and it'll be up to each different project to decide how they want to participate. So I think to close it out, we'll talk a little bit about ancillary services. And we've been thinking here that ancillary services would be treated very similar to how we treat other resources, where they'll have to be scheduled within the economic max, or in New York we refer to it as the upper operating limit. And so, for example, if the upper operating limit was 5 megawatts, that 5 megawatts caps the amount of energy and reserve that can be provided in the same interval for the resource. Likewise, we thought about how providing ancillary services should affect the state of charge calculations. And we determined that for now, we're going to treat regulation as having no impact on the state of charge calculation. In other words, we're thinking about that as being neutral, and therefore it would not add to or reduce the megawatt hours that are part of the energy level. If you go to the next slide, in this area, we did get some feedback from our reliability coordinators, and we want to make sure that as we qualify these assets to be reserve providers, they meet the MPCC criteria of having at least an hour's worth of discharge capability, and the storage will be responsible for managing their physical energy level. So as much as we are going to manage the schedules to make sure the schedule we provide the asset falls within the physical range, it's still up to the asset to follow those dispatch signals and make sure that they can continue to meet the future schedule. So the ISO won't be taking on any of that obligation, even in its NISO managed option. So with that, the last slide really provides a lot more links on other material if you're really interested in the details, the really nitty-gritty details of what the design is shaping up to look like. And so there's some links here on past presentations and documents that really get into the meat and potatoes of the design. So thank you for your time, and I'll turn it over to the next speaker.
Great. So thanks, Mike, for that. Our next speaker is Laura Walter from PJM. So Laura has been involved in strategic market design efforts and economic issues at PJM for a long time, and she is leading the team to implement FERC Order 841. So with that, Laura, the floor is yours.
Hi, this is Laura Walter. Can you hear me?
We sure can. Thank you.
Oh, good. I was having a little bit of technical difficulties on my side, so that's wonderful to hear. So yes, this is Laura Walter at PJM. I'm in our Advanced Analytics department, and if you could go to the next slide. So PJM is a regional transmission operator of the bulk electric grid. We have over 1,000 member companies, almost 180 gigawatts of generating capacity. We're 13 states, DC to Chicago, and cover about 240,000 miles of territory. Can you go to the next slide? So PJM operates the grid in this area, but we also run markets surrounding that. So that would be real-time, day-ahead, and longer-term markets, which include financial transmission rights and capacity. We actually do a capacity auction 3 years in advance to the actual delivery year. So PJM works both in grid operations and in markets. And those are my two standard PJM slides that everybody gets. Just go to the next slide, please. So we're seeing an unprecedented number of changes in the power industry. Certainly the growth of gas, particularly in our region, we're sitting on Marcellus Shale, and we're seeing a lot of cheap gas come in. We're seeing additional coal units retiring. There's a lot of things changing, including we're starting to see a lot more interest in distributed energy resources. We don't have the growth of intermittent that you would see, say, in California, where they're experiencing the duck curve, but we do see a growth in intermittent and renewables. It's about 5% of the energy in a year is coming from renewables within PJM. Also, we're seeing alternative technologies, and it makes for a very interesting time for 841 to be happening and us to take a look at what are the best ways to comply. So if you could go to the next slide, please. So currently in PJM, we have over 5,300 megawatts of what FERC would define as electric storage resources. So about 96% of that is pumped storage hydro, and these are hydro units that are kind of arbitraging LNP between different periods and pumping up to the top of the pond for later generation using that water. That's where most of our electric storage resources are right now, and they've been there for quite some time. They currently operate in capacity, energy, our regulation market, and reserves. Now, I do have another 4%, which is mostly batteries, and it's sitting in different places, but all my battery storage is participating in the regulation market. Specifically, we have a fast-moving regulation signal where most of, all my batteries are, and that's how they're getting revenue through PJM currently. Could you go to the next slide, please? So PJM doesn't have a straw proposal out currently to comply with the order. What we have laid out is a way to get to a straw proposal. So although we have the governance that was explained earlier, it's a little bit different with a compliance filing. So what we'll do is we'll go through sessions to get stakeholder feedback on the compliance filing. So we'll go through, we had one earlier today that says 1 to 4, but really it's over. It was 9 to noon Eastern. Going forward, we'll ask for feedback. We'll put out a straw proposal at some point, continue to get feedback, and then our hope is to report out to the different committees. That's the PJM Operating Committee, Planning Committee, Market Implementation Committee, and Markets and Reliability Committee on those dates in October. That gives us additional time to make all the changes to our tariff and governing documents to comply with the order by December 3rd of this year. Next slide, please. So most of my presentation is actually about status quo as it is right now because we don't have a straw proposal. So currently I do have pump storage in my market. It either self-schedules or uses the pump storage hydro optimizer in our day-ahead market. What this is kind of a legacy system that's been around for some time that looks at pond levels and in the beginning of the day and end of the day, and along with some other parameters, gives a schedule day ahead for pump storage hydro. We can't really leverage this to comply with Order 841 because it first doesn't really scale, as it is kind of a legacy system, and then also because part of the requirements to use this optimizer is that you need to give us a zero cost, and we don't consider cost in your schedule, but also you can't set price. And as was explained earlier, setting price and being dispatched is part of the requirements of the order. Other storage doesn't participate in the energy market currently. That is in part because you can't offer in negative megawatts with a megawatt price pair currently in PJM. So we're not seeing other resources come in, possibly because of the design or possibly because of other reasons. So certainly we have to look at making sure that it is available for other storage resources under 841. Next slide, please. Where all my batteries currently are is in Reg D. So PJM has 2 regulation signals, and we both have regulation up and regulation down in one signal, and it's one product. So we have the 2 signals are Reg A, which is for slower moving thermal resources, and Reg D, which the D is for dynamic. It's for batteries, flywheels, and hydro. It's faster moving, but also will cross the zero line. So for batteries over a certain time period, it won't overly discharge the battery. It'll come back around and follow that kind of zero center. We did enact a non-energy resource option for regulation in 2013. So the way that it always had worked was you offered in to energy, and then you also offered into regulation, but we determined your lost opportunity cost for providing regulation based on your energy schedule. So the issue there was is that you could have been picked up for energy. So we found that resources didn't want to be picked up for energy, they just wanted to provide regulation. And so we did put in this option in 2013, which is one of the options that FERC kind of encourages ISO to look at ancillary services without an energy schedule in the order. We did have a change in our Regulation D signal in January of 2017. There is a FERC technical conference forthcoming. However, I hear that that's been delayed to come to agreement on some of the issues that were before FERC prior to that technical conference. So that is currently going on at the same time as our compliance with Order 841. Next slide, please. So for capacity, currently the rules are structured such that megawatt hours for a duration limited resource, or actually any energy storage resources, would need to be derated by the duration requirement. And the current requirement is a 10-hour requirement, although I will say that we did have a market implementation committee discussing this, and there are different views. PJM's view is that it is a 10-hour requirement. The market monitor believes that it's a 24-hour requirement. And then some stakeholders believe that it is more like a 4-hour requirement or less based on status quo. What will need to happen is that we'll need to get a lot of clarity on this in the process going forward. And then when we file the compliance filing, we need to make sure that it is extremely clear, so we don't have these discussions where, you know, we believe currently status quo is X, Y, or Z. That being said, a 10 megawatt hour energy storage resource under the 10-hour duration requirement would be able to offer a maximum of 1 megawatt as capacity. So that's the current setup, and this is also what we are getting stakeholder feedback on going forward. Next slide, please. So this is kind of emerging right now for PJM. If you're interested in giving PJM feedback, you can reach out at esr@pjm.com, and we have a team kind of going through this and working on the compliance filing and the design. But also, I encourage interested parties to sign up for the MIC Electric Storage Resource meetings, and the link is here. We have 3 more sessions scheduled right now, and we are hoping to be presenting our straw proposal soon, and to receive additional feedback as we go along, either prior to the straw proposal and after. And that's all I have.
Great, thank you, Laura. So looks like we might be going a little bit over, so audience, if you can plan accordingly. And our next panelist, if you can keep to 10 minutes, hopefully we can get through everything. So now we're going to turn it over to Kevin Benoit from the Mid-Continent ISO. So Kevin has been at MISO for almost 15 years now. So he has been leading the market design efforts there with respect to Order 841 compliance. So Kevin, turning it over to you.
Thanks, Mihir. Can you hear me?
We sure can.
All right, great, thanks. If you could go to the next slide. So just to give you a refresher on MISO, our footprint covers 15 states and the Canadian province of Manitoba. Our peak system demand is about 127 gigawatts. We have approximately 18 gigawatts of installed wind on our system, and that's located in our north region, or the blue region on the map here. And we have a little bit of storage, which I'll cover on the slides or cover in a minute. We also have some solar that's starting to pop up on our system in different regions, but right now it's less than a gigawatt. So next slide, please. So in MISO, we've had pump storage, about 2.7 gigawatts since we started our energy markets back in 2005. We provide for use limited or energy limited generation schedules in our day ahead market as well as in our capacity market. We have a 4-hour duration requirement, so we allow that type of storage to qualify under our capacity rules. We support them participating as generation resources, which requires them to self-schedule or to use virtual schedules to reflect their charging or their pumping in the day-ahead schedule, in the day-ahead market, which we're hoping to expand with Order 841. Since 2009, we have supported short-term storage or flywheel battery type storage, which typically is less than 1 hour in duration. It has been able to provide ancillary services only, so regulation only. We've got some logic in our regulation deployment, which considers the state of charge of those resources as they get closer to a maximum or minimum state of charge. Our deployment logic looks to move them closer away from those limits on a deployment opportunity basis. We recently modified one of our resource types to better accommodate storage, and we created what we call our Stored Energy Resource Type 2, which gets us closer to 841, but still some work to do. And this provides for resources that do have the ability to go from charging to discharging, or injecting to withdrawing from the system to charge and discharge. And we'll be replacing that resource as we go to comply with Order 841. This type of resource can provide energy, ancillary services, and capacity. And as of yet, we don't have any registered assets, but may see some in the interim period as we look to comply with Order 841. So next slide, please. So right now we have 3 grid scale, other than our pump storage, we have 3 grid scale battery type units. So that includes a 20 megawatt facility in Indianapolis Power and Light, Entergy New Orleans with a 1 megawatt utility scale solar battery and storage, and then a 7.2 megawatt battery up in the northern region. So we have 120 megawatts in our interconnection queue under definitive study, as well as a total of 475 megawatts that have been added in the last 3 months. And as we've seen prices and interest in storage grow, we're seeing more interest in interconnecting to our system. We don't expect batteries to have a significant impact on the MISO market in the near term, just given the levels that we're seeing in the interconnection queue. But as prices continue to drop, that's sure to change. So our near to midterm activities are to comply with Order 841. But in the long term, we see storage as having a significant impact on the markets and on the footprint. And so we're looking at enhancing our Order 841 compliance, filing with enhanced modeling of storage, moving more to optimization of the resources in our markets. We also established an energy storage task force in mid-2017 to start defining issues and working those through the stakeholder process. And so that gave us kind of a running start on Order 841 compliance, working with our stakeholders on issues that are important to them when it comes to storage. So right now we do have those two types of storage resources, kind of the short-term and the longer-term storage. Our goal is to move to the electric storage resource, which will comply with Order 841, and then in the long term to have an advanced electric storage resource that can provide all the value and also be optimized by the RTO. So next slide, please. I won't cover this one as Mahir covered that previously. Just an overall view of our Order 841 compliance. We're looking at the specific requirements of Order 841 and those meeting the definition of what FERC defined as an electric storage resources, including resources connected to the distribution system. Our goal as FERC's was just to remove barriers to participation and also provide compensation for non-market-based services. There was a list of things that FERC put beyond the scope of Order 841, but we want to make sure that those are future items that we address, and those include things like managing the state of charge and optimization of those resources, as well as things like hybrid resources or distributed energy resources. Next slide, please. This is a depiction of the four modes that we're going to provide for electric storage resources. And so as they are available to the market, they can offer in one of four different modes, if they're not available to the market, they would be offline or in the outage. That's kind of the lower left-hand quadrant. And then discharge mode would be when they were really acting more like a generator with minimum and maximum limits, and we would dispatch them economically between those limits based on their offered curve, their two-part offers, or their price megawatt pairs between those limits. And then similar to that, when they were looking to charge, they would be offering in or in charge mode, and we would dispatch them to withdraw between their minimum and maximum charge limits at their charge ramp rate, and also look at constraining their amount of charging based on their maximum state of charge. And then the continuous operations mode, and this would be for a resource that could go from charging to discharging within any given dispatch interval, and we would respect their maximum charge and maximum discharge limits, as well as their minimum and maximum states of charge. And so looking at the next slide, this is kind of what continuous operations mode would look like. So between their minimum and maximum, it would show our unit commitment and dispatch system would create their set dispatch targets based on their economic offers between their minimum and maximum limits for any given dispatch period. The next slide shows what the operations would look like under charging or discharge modes. And so if they were charging, we would set their dispatch targets at or below their minimum charge limits. And if they were discharging, it would be in between their minimum discharge and maximum discharge limits. On the next slide, I've just summarized that our approach, and I've provided a link to some meeting materials to our straw proposal, which we rolled out to our stakeholders last week at a stakeholder meeting, so you can find that on our public website. In all the modes, the market participant would be managing their own state of charge. We would be providing their offer parameters and characteristics to allow them to do that. And these would be considered kind of must-run commit status. So they would be telling us when they were available to operate in these different modes to manage their states of charge. The next couple slides just talk about where we see storage going into the future. So next slide. We see that storage may provide multiple value streams, including transmission and distribution services, and want to make sure that we're accommodating those and the work that we're doing with our Energy Storage Task Force, as well as working on interconnection rules and other transmission planning aspects will also address those things. We also, in our market systems enhancement, that'll enable us to optimize use of storage through the different modes and reflecting that in our commitment process and further optimize between pumping and generating cycles for, say, pumped hydro. And then in our market roadmap, we also intend to address the enhanced storage resource type to more fully utilize these resources. And with that, say thanks to Mahir and the group for inviting us today, and turn it over to the next speaker.
Thanks, Kevin. So our next speaker is Chris Parent, who is the Director of Market Development at ISO New England. So Chris has been working with a lot of market design issues related to energy storage. And Chris, I am turning it over to you.
Thank you, Mahir. So we're going to spend a little time just walking through where we are currently at with storage and kind of prospectively what we think we need to do with Order 841. We can kind of go to we can actually skip slide 2 and go right to slide 3. So slide 3 gives some context for the region and just where we're located. We're not maybe quite as big as our friends at MISO and PJM, but we have peak loads historically of 28,000, but has been more in the 25,000 in recent years with the large growth of energy efficiency and behind the meter solar driving those numbers down. And we actually are starting to see a lot of interest in storage as well in the region. You can go to the next slide. Our interconnection queue currently has about 500 megawatts of new storage. That's at kind of bulk power system interconnected. Massachusetts has a lot of interest in storage and has policies and programs they are running to incent storage. So we will expect to see some of that showing up in kind of the behind the meter DR space as those projects come to maturation. We also have on our system nearly 2,000 megawatts of pump storage, as well as 17 megawatts of battery storage operating in the markets. You can go to the next slide. So with the interest in storage that we kind of saw coming, in 2016, we actually proposed a set of changes to improve how we enable battery storage to participate in the markets. And since that point, we've been actually working to kind of figure out precisely how to implement all those changes. So this summer, or I guess this spring, we started a stakeholder process to start looking at the changes we made in 2016 and adding more detail and information around precisely how these would work. And I've included links to the stakeholder material that's available for you. We've been out since April with our NEPOL Markets Committee talking about this topic. And these changes really enable storage to fully participate, where before they were able to participate, but maybe not in the ideal fashion. So we can go to the next slide. So when we look at what the new changes we have or we're proposing, most of them are focused on the real-time market. But in the context of New England, really all of our markets are geared on delivery of energy or reserves. So even in our capacity market, it's really indexed the ability to provide energy and reserves when the system's needed. So while storage could participate in the capacity market before we made these changes, really enabling them to participate more robustly in the energy market makes it much more practical for them to participate in our capacity market as well. So they will be able to participate in the capacity market fully as supply with these changes. They will also be able to fully participate in the energy market as both dispatchable supply and dispatchable demand. And when you think about the Order 841 requirements, What we look to do is, they can set price as supply and demand, which is a really important component. They'll have access to nodal LMP. They'll also be eligible for uplift, which in New England we call net commitment period compensation, and they will both be eligible for uplift both when they're consuming as well as when they're supplying power to the grid. They will also be able to manage their state of charge through the ability to offer and bid into the market, as well as set dispatch limits that respect their physical characteristics and their state. So the ISO at this point has no plans to really institute a model where we would be managing the state of charge for a participant, and rather we're going to allow the participant to do that through their offers and bids and their physical limits. So the big change we were making with this was really enabling storage to be able to provide reserves and counting on those reserves properly. So these changes enable storage to provide spinning reserve both as supply and demand. And by being able to provide those reserve products in real time, they'll also be able to sell that through the forward reserve market forward for delivery in real time. Finally, we leveraged our existing regulation market structure, which is what we call an alternative technology regulation resource, which enables the ability for storage to follow an energy neutral signal to kind of complement the participation in the energy and reserve market. And really this ability to link concepts of being demand in the market, supply in the market, and being able to regulate in the market on an energy neutral signal was really the big effort that we did. And by linking all these together, being a generator, being what we call a dispatchable asset related demand, and being an alternative technology regulation resource, it really enables storage to provide all the services in real time, kind of based on the physical characteristics of their facilities. Next slide. So kind of building on, kind of driving into how we enable the dispatch limits and participants to manage their state of charge in the energy market. We're going to require that storage provide us two telemetered points. One is the available energy, and one's the available storage. And the way to think about the available energy is that's the amount of room, that's the amount of energy that is in the battery. And available storage is the amount of energy that can be put into the battery based on where it's currently at. And by having that information, we can actually calculate the dispatch limits so that whenever we're dispatching the facility, we dispatch it within its physical characteristics. We're not asking it to consume more than it could consume. We're also not asking it to supply more than it would be physically able to deliver to the power system at one time. So those changes respect the physical characteristics of storage, but they also allow us to do things like reserve accounting properly. Mike mentioned in New York they have to respect the MPCC guidelines related to 1 hour of sustainability to provide reserves rather. So when we have the available energy information, we can properly account reserves in real time on these facilities as well. Also, an important element of Order 841 was ensuring that they didn't get storage devices didn't get conflicting dispatch instructions. So while we are representing storage effectively as three distinct things within our market, a generator, a DART, and an ATR, they would only ever receive a net dispatch instruction for us, so that there would be no confusion as to where the ISO wanted them to be at any point in time. Finally, and this is important because of how we chose to model them, we had to take the current cost allocation treatment we apply for pump storage facilities, which actually exempts storage from specific costs, and apply that kind of uniformly to all storage within the marketplace. So that is also part of the proposal, where they're going to be exempt from market costs when they're effectively providing those services. Next slide. So those changes that we've proposed, we're actually targeting to implement early next year. So from our perspective, we've actually are far along the process of being compliant with Order 841, but there is more work to do still. So we recognize that things like the size limit and other aspects of what FERC is asking for in Order 841 will require additional changes, additional stakeholder process, and an additional filing later this year. So from a timing perspective, we're hoping to have a vote on our proposal with our stakeholders in July and a filing in August, so that we can be in a good position to implement the changes that we've proposed in that early 2019 timeframe. And then between August and really the December filing date, we'll be working with our stakeholders to address any gaps in what we've proposed for that early implementation. You can move to the next slide. This just provides a nice picture of where we're at kind of collectively with storage participation. We have our pump storage model, which I didn't speak to a lot, but the pump storage model really is for fast start resources and reflects the fact that certain storage facilities may have to transition from charging to discharging or vice versa. So this model works really well for the storage for our pump storage facilities, and it already enables them to be able to set price and be paid for uplift and those type of things, which are core parts of the Order 841 changes. The battery storage model doesn't have those transition concepts. So really, what we were doing with the changes we made was really enabling that kind of very flexible transition from charging to discharging and properly accounting on the resource in that manner. We are maintaining our regulation-focused option where a facility could come in and just choose to participate in the regulation market. So there are no changes to that model, which is what we call our alternative technology regulation model. And storage can continue to participate as demand response when it's behind the end-use meter, using the fully integrated demand response rules that we implemented on June 1st this year. And those rules really provide a nice set of options for storage that may be behind the meter, as they are able to provide capacity, energy, and reserves as the dispatchable demand response. And those facilities could also elect to aggregate and participate as an alternative regulation resource to regulate in our markets as well, depending on how they wanted to participate. While we have more work to do, we actually feel good about where we are at and are really looking forward to implementing a lot of these changes that we think really will enable battery to storage to participate much more robustly in our markets and provide the services and kind of benefits to the system that they can deliver with their very fast performance and response to system needs. Next slide. So to wrap up, storage is obviously the technology that we focused on today, but we are continually looking at our rules and trying to better figure out how to integrate storage and other technology into the market. And how we can improve that. We think getting these changes implemented now and getting storage using these changes will provide us a lot of really useful feedback on ways we can improve and further enhance both how we model the technology and our market design as a whole, so that we are continuing to respond kind of the future need of having flexible resources on the system to help balance the variety of challenges that we see in the future with both renewable integration, pipeline constraints, and other things that at least the New England region is facing today. So thank you very much for your time.
Great, thank you, Chris. And thanks to all our panelists. We really appreciate the content and all the perspective that you have. There's some great information here. So I was going to run through SVP and CAISO, but in the interest of time, I'm just going to upload the slides and you can take a look at those updates. We do want to open it up to Q&A, but first, Mark here has a couple words.
Yeah, so obviously the slide deck will be posted, and it should be a great resource for our participants who are interested in what's happening on an ISO by ISO basis for storage as a market participant. I also wanted to highlight, though, that Sandia National Laboratories posted developed a white paper a couple of years ago on this very topic, and we provided a link here on this resources page, so you can go click on that, download it, get a lot more information on what Sandia identified as various policy barriers to energy storage deployment. Our very own Mihir Dasu, who is the moderator today, is also kind of a national expert on what's been happening with wholesale market design and the economics for energy storage throughout the different ISOs in the country, so you can feel free to reach out to him. Also wanted to flag the Energy Storage Association as a good resource for those who are following the FERC issues. And then, next slide, please. The California Energy Storage Alliance is another great resource, particularly for what's happening in California, but the policy experts at CISA have a really good foundation in what's happening nationally as well, so they're a good resource for folks to reach out to. Now we're going to turn it back to Mihir to start to go through some of the Q&A. We're going to try and stick on for another 10-15 minutes or so to try and get through as many questions as we can. We've got a lot of great questions today, and we'll also allow the panelists to have access to all the questions, so if they want to reply directly, they can.
All right. Thanks, Mark. So one of the questions that we've gotten a lot of feedback on is storage is a transmission asset. So CAISO has been going through a stakeholder process, and some of the audience members are curious as to the other ISOs, their perspective on that, especially with regards to bifurcating storage as both a transmission resource and a merchant resource. So why don't we start with Chris?
I think so. So this is something we're aware of, and we're actually watching closely what's going on with California. Our current rules don't really allow that sort of option. That would have to be a special petition down for FERC when you start talking about it as a transmission asset, just in the context of how kind of our transmission planning process is structured. There are a lot of I guess from kind of my perspective, my initial reaction on this has been there are a lot of challenges as you start thinking about that and how it's used and what's driving the behavior of that function in the market, as well as the very complicated questions around cost recovery and things. But at this point, I would say we're monitoring. We don't have any specific plans to take action to change our rules, but we're keeping an eye on the situation. We're watching what's going on in California, and obviously listening to people as they raise questions and talk to us, and kind of collecting information to better understand kind of the perspectives and maybe how we should proceed in the future.
Laura, do you have any thoughts? Storage as a transmission asset in PJM?
Laura, I think you're muted.
Sorry, I was having difficulty unmuting.
No problem.
So we are looking at this early stage of electric storage development we believe that the demonstration of projects and learning through the selective deployment based on engineering judgment would be probably the best way to move forward. But the planning process needs to consider many more time-limited based options, such as those considered in PJM operations and assessing solutions to reliability violations. We're looking at this going forward and considering piloting, but that's all I have for PJM on this issue right now.
Thanks, Laura. Kevin, do you have any thoughts?
Yeah, thanks, Mahir. So MISO is, we're probably monitoring it as well. We're working through, what this might look like going through our transmission expansion planning process. We don't have a straw proposal in the works right now, but we're continuing to have discussions with stakeholders around what this could look like. Obviously, from a pure transmission asset standpoint, that's probably easier to get rules around from a cost recovery and perspective, but something that we're continuing to work on and feel it's an important issue to tackle as we move forward with more storage on the system.
Great, thanks, Kevin. So Mike DeSocio from NISO had to drop off, but he asked if you have any questions, feel free to send them his way.
And clearly there's a lot going on in NISO and on this particular topic as well. So unfortunately couldn't hear from him today, but you've got his slides and you can contact him with the information we have today.
Great. So next question is about behind the meter assets. Could the panelists briefly touch on how they're handling wholesale market participation for DERs? And let's start with Kevin.
I think he's muted.
Okay. All right. Let's go to Laura if you're still on.
Sure. So PJM had a distributed energy resources subcommittee where we're working through all the different issues associated with anything at the distribution level. And that's where most of the discussion is happening for behind the meter. We do have a definition of our tariff of behind the meter, and it's capital behind the meter. And part of that definition is that they don't inject. So there's currently discussions to figure out what's the best way we can talk about this in a way that makes sense, and what are the best rules moving forward. But that's currently under development here at PJM, and that group meets monthly.
Great. Thanks, Laura. How about what's going on at ISO New England, Chris?
So as I mentioned kind of on that, there's that summary slide in that table which helps provide some context. But so for smaller facilities, that are behind the meter, really the demand response model is really, I don't say what you'd expect them to use, but in many cases what you'd expect them to use in the current construct. That enables both aggregation as well as full access to kind of all the markets. I also mentioned that we have our alternative technology regulation resource model, which also allows for aggregation kind of across a very diverse or broad geographic area. So those are two ways where facilities that are behind the meter can participate in the markets. In regards to DERs in general, we also have a settlement-only generator model, so things that may be small but not behind the meter. And those facilities don't actively participate in the market, they're just price takers in real time. But they're able to, if they're greater than 100 kilowatts cell capacity, they're able to gain access to the real-time energy price. And if they really wanted to, they could also regulate as an ATRR. So small facilities do have a number of options in the market to participate. That have seemed, at least to date, worked. But as I expect, as we get smaller storage facilities behind the meter, there may be an interest to determine how we would treat them maybe differently than the demand response model treats them. And that's a discussion that I kind of look forward to having as we kind of get more experience with how those facilities are participating in the wholesale markets.
Thank you, Chris. I just want to ask you and Laura if you have time for one more question.
I do.
Okay,
sure.
Great. So the last question is about hybrid storage plus generator resources. So there's a few questions around how your respective ISOs handle the interconnection agreements. Do they have to file separately? And let's say you have a hybrid resource and the generator retires, can the storage unit then participate? And let's start with you, Laura.
So I definitely have hybrid resources in the queue. And through this kind of stakeholder process, we're also looking to create rules to figure out what to do with these hybrid resources. For the question, if you had a generator and a storage together and the generator retires, right now I don't have storage operating in my energy market outside of pump storage hydro. And you can't offer negative megawatts, so you can't offer the curve. So you couldn't, as of right now, you couldn't be able to. That is something we intend to address with our compliance filing.
Thank you, Laura. How about you, Chris?
So the question I heard is, how do hybrid facilities participate in interconnect? And the retirement question I don't fully understand, but the question I will answer is that if you had a facility retire that was using the same interconnection, where maybe that interconnection was constrained, could the battery then take full advantage of the interconnection space? So in the first question, we don't have any. Well, we do have some in our queue. We don't have any hybrid facilities currently participating in the markets, like solar and storage, for example. Our expectation generally would be that they would participate distinctly in the markets, especially the larger facilities, so that we would be able to dispatch the solar and the battery independently. That gives us kind of access to be able to optimize and count reserves and things on the storage facility separate from the solar facility. We do appreciate there can be some metering challenges with that position, and we have been talking to folks to better understand what those challenges are and maybe different ways we could configure the metering to gain access to that information. For smaller facilities, that we are not dispatching in the market that choose to participate, we are effectively okay with them coming in as a composite facility, as our real motivation is trying to gain access to be able to dispatch them and count reserves on them properly. So with our settlement-only facilities, they're really just participating in the market as price takers, and they're participating in the capacity market as well. So while sometimes we have to work closely with the party when we're qualifying the facility to determine how many megawatts they're eligible to provide capacity for of the composite facility. We'll effectively allow that to be a composite combined facility in the marketplace. In regards to the interconnection question, I guess there are many ways to interconnect to the market when you're behind the same point of interconnection. And this really requires a discussion with us to figure out how you want to approach it. It is possible to have one interconnection that actually supports both facilities, one interconnection request. However, contracts and arrangements have to be put in place between the parties so that there's agreements in regards to outage management and who's taking care of what, and also who has access to things, especially if the interconnection point is constrained for some reason. So that ends up being a coordinated process. It's also to submit separate interconnections for those too. And then I would say on the retirement comment, sort of the same issue. It gets into how it's structured, and when you're retiring a facility, what are you retiring? And I can't say right out of the gate that under all circumstances the facility would maintain access to the interconnection, but I'm sure we could come up with cases where they would. So with many things with storage, I guess the feedback I often give is it's complicated, it's unique, and it's very site specific, and we really need to walk through the configuration and the use cases so we understand what the party is thinking, and we provide guidance so that they are well informed on both the investment decision or the retirement decision, depending on the what side of the equation you're looking at. Things like inverter constraints there's additional constraints in things, especially when you're getting to the inverter technologies, that have to be layered in and understood so that we can really help folks make informed decisions about how best to enter the market. So hopefully that answers the question that was asked. But I would say kind of universally with storage, it's always good to just pick up the phone and give us a call and walk through what you're thinking, because there's almost no general answer I can give that covers everything until we actually go through precisely what the party is thinking to do.
I think that's a great rule of thumb for kind of the state of the industry right now is, if in doubt, ask the question. And it sounds like Kevin actually hopped back on to continue the Q&A, so just wanted to give Kevin a chance to answer this question as well, if you have any additional thoughts beyond what Laura and Chris already said.
Yeah, thanks. I would just echo Chris's advice to pick up the phone and give us a call. I think we're in the middle of complying with Order 845, which deals with interconnections. We feel like a process we put in place a couple years ago that we called Net Zero, that contemplated interconnecting different resources behind an existing point of interconnection, either through a transition or something like a hybrid resource, is fairly consistent with what Order 845 is trying to accomplish. And so, but definitely work with our interconnection folks to do that. And I'd also echo Chris's thoughts on with these resources. We really think that they need to be treated separately from the dispatch perspective in our markets, because it's a different economic and dispatch model for the renewable and the storage. And so I think it gives the owners and operators the flexibility to offer the two assets, per the economic goals that they're trying to achieve, and it gives us the ability to model something that looks and feels like something that exists today, which is an intermittent resource and a storage asset, as opposed to trying to come up with more complex modeling. So with that, I'll turn it back over to you.
Thank you, Kevin. Well, we are running way over here, so I just wanted to give our panelists, Kevin, Laura, Chris, and Mike, a solid thank you for your time today. I think this was extremely educational, great content, gave folks a really good opportunity to get an overview of what's happening nationally on this topic. Also wanted to thank Mihir for his excellent facilitation, as well as Jackie Hernandez from Sandia National Labs and Imre Juk from DOE's Office of Electricity. So thank you very much. We'll be getting the slides posted shortly, as well as the recording posted for those who are interested in a memorialized copy of this, and also be posting all the resources that we mentioned. Thanks again for participating, and make sure to tune in next time, July 12th, for our webinar on behind the meter storage rate design trends. Take care, everybody.